Hello everyone. Today, we're going to learn the basics of coffee roasting. For a long time, the roasting of green coffee beans has been seen as a mystery by industry professionals and even regarded as a kind of mystical art by many. Even though we have over a century of roasting history, its rules have rarely been truly documented in literature or through scientific methods. Ideally, a roaster would learn from an experienced and skilled master trying to find their own path. But more often than not, the reality is that young roasters explore and experiment alone, learning through trial and error. Roasters rely on countless batches and tasting endless pots of beans, passing down plausible-sounding theories by word of mouth to build up a system. Many spend years lost in the labyrinth of roasting, filled with failures and experiments. Just when they think they've made some progress, they often find themselves taking 2 steps forward, only to take 1 step back. Roasters are eager to find a theoretical foundation to support their roasting beliefs, a basis that can prove itself in blind tests while being applicable to all bean types and roasting machines. Now, roasters have incredibly powerful analytical tools to track and measure results, making the roasting process more consistent and predictable. Adhering to systematization and objectivity, validated by data, we can directly view the roast curve on a computer screen. We sincerely thank these pioneering scientists and coffee masters for allowing us to stand on the shoulders of giants, achieving successful roasts time and again to brew a great cup of coffee. There are many factors: coffee variety, processing method, green bean selection, etc. All are crucial in determining coffee quality. Here, we will focus mainly on the coffee bean roasting stage. First, let's talk about the meaning of roasting. 1. Definition of roasting. So-called coffee roasting refers to the heating of green beans, triggering a series of physical and chemical changes inside and out. And in this process, it generates various flavors of coffee such as sourness, bitterness, and sweetness, forming purity and hue. The process of transforming green beans into dark brown, round beans. 2. The importance of roasting. Among the factors affecting the taste of a cup of coffee, green beans account for 60%, roasting accounts for 30%, and extraction accounts for 10%. Good roasting can bring out the character of the green beans to the fullest while minimizing the occurrence of defective flavors. Conversely, improper roasting can completely ruin good beans, because during the roasting process, controlling heating time and temperature is very difficult to grasp. Roasting technique is a very complex skill. Therefore, the importance of roasting becomes even more prominent. Roasting coffee beans has 5 stages. 1. Drying. Drying is the first step in coffee roasting. Coffee beans themselves are plant seeds, living and containing moisture. The temperature for roasting and drying is below 170 degrees Celsius. Due to differences in roasting equipment and the beans themselves, the drying time is also not fixed, generally 5 to 8 minutes. Dried beans are rich and mellow. However, many roasters use the term drying zone, a somewhat misleading term, to refer to the first few minutes of the roasting process. Coffee beans in the first 60 to 90 seconds of roasting do not release moisture, or only release a small amount of moisture, because all beans have not reached the boiling point of water. In the following few minutes, the moisture in the coffee beans will be released at a high and stable speed because from the outside to the inside, the bean layers sequentially reach the boiling point and begin to release water vapor. Here, no definition is given for the drying phase. It only explains the reason why drying occurs during coffee bean roasting, but it only mentions the boiling point of water and does not mention the concept of evaporation. These are the most basic concepts we learned in physics class during our school days. Evaporation and boiling. They are the two ways that cause a substance to change from a liquid state to a gaseous state. Evaporation can occur at any temperature. It is a vaporization phenomenon that generally occurs on the liquid surface. Boiling occurs at a specific pressure. When the liquid temperature rises to a certain degree, rapid vaporization happens simultaneously on the surface and inside the liquid. From the moment coffee beans are loaded into the roaster's drum, they begin the endothermic stage of absorbing heat. The green coffee beans first meet the evaporation condition and slowly start to release moisture. Once the entire bean, inside and out, fully reaches the boiling point around 100 degrees Celsius, it begins to accelerate the rate of dehydration by releasing moisture. This stage is the optimal phase for rapid moisture release, not the final stage. Regarding the dehydration phase of coffee bean roast, there doesn't seem to be a definitive consensus yet. Some refer to the stage before the green beans turn yellow as the dehydration phase. Others say dehydration runs through the entire roasting process, from start to finish, until the beans are dropped. As for which statement is more accurate, that's not really the point. The key lies in establishing a framework of understanding and a process that requires further exploration. During the roasting process, coffee beans are continuously heated, causing moisture to evaporate and the beans to gradually lose water. And during this water loss process, what happens that leads to the weight loss of the beans? 2. Temperature. Professional term. In simpler terms, it means heating up. When roasting coffee beans, the optimal temperature rise is generally controlled around 8-12 degrees Celsius. Why is it that with the same batch of green beans, some roasts turn out more bitter, while others are more acidic? The temperature rise phase is crucial here. Too low a temperature leads to more acidity, and bitter notes become relatively prominent. Additionally, if the beans are fresh, with higher moisture content, the temperature rise should be slower to allow sufficient time for the moisture to volatilize. If they are aged beans, which tend to be softer, then it's time to get it done quickly. The longer it takes, the more flavor the beans will lose. A detailed look at temperature rise in roasting. Roasters often mention ROR during roasting, short for rate of rise. ROR is a crucial concept in coffee roasting. It indicates the rate of temperature rise of the coffee beans, typically recorded as the temperature increase per minute. This metric can be used to judge the roasting rhythm. Roasters can observe the ROR value changes to adjust the heat and achieve the desired roasting outcome. During the roasting process, the ROR curve differs from the bean temperature curve. It presents a line that changes with the roasting time. In the initial stage of roasting, the air temperature may show a negative growth rate, but the drum temperature and bean temperature will eventually balance, known as the turning point. Starting from the turning point, the ROR value begins to show an upward trend, peaking and then gradually declining to balance. The roaster's goal is to keep the ROR value in a steady, declining state to avoid disrupting the development of the coffee beans, especially after the first crack. To preserve the inherent sweetness of the beans and avoid leaving only the taste of roast. Therefore, understanding and controlling ROR is very important. For coffee roasters, it helps roasters better master the roasting process, resulting in coffee beans with superior flavor. 3. Smoke exhaust. Green coffee beans are mostly lignocellulosic fibers, containing many compounds inherently. Roasting involves extensive chemical changes, thus producing smoke. If smoke cannot be vented promptly, it increases the smoky flavor in the bean. Generally, smoke exhaust begins during the temperature ramp-up phase. Smoke volume increases significantly at the first crack. The darker the roast, the more smoke is produced. It peaks during the second crack. 4. Coasting and roasting refers to cutting the heat, much like letting food cook through with residual warmth after turning off the stove while stir-frying. Nevertheless, the roasting of coffee beans involves far greater complexity than the simple act of stir-frying. When beans in the roaster are continuously heated, first crack, second crack, reduce heat before the exothermic process coasts. Excessive heat can overmature the beans, creating a spicy sensation. 5. Cooling. Rapid cooling can effectively lock in the aroma of the coffee bean. After completing the above stages, remember to seal the roasted beans. The entire coffee bean roasting time, it's best to keep it between 9 to 12 minutes. The specific roasting of coffee beans depends on the characteristics of the particular beans. Differences in each step can create beans with distinct flavors. And since everyone's preferences vary, coffee bean roasting becomes endlessly fascinating.